Hey guys, this is Mitch with Finepoint CGI, and today we're going to build a scalable inventory system. We're going to go through the process of building out the inventory itself. We're going to talk about how to add and remove items from that inventory. We're going to talk about how to click and drag those items, and we're going to talk about how to delete those items. We're also going to talk about how to create a scalable item that can be reused throughout your entire project for any item that you ever need to make for an inventory. And finally, we're gonna upgrade to Godot beta 14 for our horror game, and it's going to break a bunch of stuff. So it will be a lot of fun. That's what I have in store for you guys today. Let's go ahead and get started. Okay, so the first thing we're gonna do is we are gonna build out our interface for our inventory. Now, basically, I'm going to build like a nice, simple user interface, and you guys, of course, can go in and make it as fancy as you'd like. But in my case, I'm just going to add in a user interface, and I'm going to right click and I'm going to add in a child node, and I'm going to go ahead and add in a scroll container. We can use this to create a scrollable inventory. Now, in my case, I don't actually need to have a scrollable inventory at all, but I figured that you guys probably do, so we'll add in a scroll container. And then underneath our scroll container, we're going to right click, add a child node, and add in a grid container. And I'm going to use that as the thing that houses our inventory. Now, the way the grid container works is if we add a child node and we add a button, and then we duplicate that button a few times. So we'll just put in 20 of these buttons. You can see right here what it's doing. So the grid container actually expands to house all of those buttons. So if we actually get rid of these buttons real quick so I can explain it a little bit better, we click on our button and we go to our inspector here, and we come over here and we grab our layout and we do our custom minimum size to about 40 by 40. And then if we duplicate this guy another 20 times, you'll see our inventory's scroll container starts kicking in. So now we actually have a scroll bar, right? We can actually use this as a scrollable inventory. But also you'll notice that everything is in one single column and it all comes straight down. Generally speaking, when you're using a grid container, you want to have more than just one or two columns, right? So if you scroll up to your grid container, you click, you can see that there's a columns parameter right here. So we'll just add in, I don't know, 4 columns. I think that will work. And now we can basically just duplicate it and give ourselves 24 inventory spaces. That way it's just a nice round number. If you guys want to do more, you can. And of course, if you want to do less, you can as well. What I'm going to do is I'm going to take my scroll container and I'm going to center align it. So I'm going to click on this guy and I'm going to hit center, and that's going to center align it within my project. I'm actually going to drag this guy over just a touch and I'll recenter align it. And I'll drag this down just a little bit as well for future stuff that we need to do. And then we need to actually code our inventory. So if we come up to our inventory, we right click and we attach a node, we're going to attach an inventory.cs. Now in my case, I'm going to make that go into my scripts folder right here. So we'll double click on that and hit open, and we will hit create. And you'll see we have an inventory.cs here. Visual Studio has opened for me. If you guys are not following the Godot horror game, then this is continuing from my previous tutorial series here, although this is a standalone tutorial. So you don't have to worry about the rest of it, but just know that that's why Visual Studio came up. If you use Visual Studio Code, that's totally fine as well. Now, inside of our inventory, we need to do a lot of stuff here. The first thing we need to do is we need to get a hold of our grid container. And then we need to populate our slots. It's okay to have your slots here, but I like to populate them through code. And the reason why I want to populate them through code versus me doing it inside of the editor is that it gives me a lot more flexibility. I can really build out my inventory and I could say, oh, you've picked up a bigger bag, so therefore you get an additional 20, inventory slots or something like that. So if you head in here, we need to set up our actual spawning system. So first we got to get our grid container. So let's come up here and say private var grid container. like that. And then on our ready, we'll just grab that. So grid container is equal to get node, and we'll pass in grid container. And then we need to pass in where our grid container is located. Now, in our case, it's scroll container slash grid container. And then all we have to do is basically populate our buttons. Now, I'm going to create a function for that. And the reason why is because when you're building functions in code, you want to make sure that everything is reusable. And there may be a time that I'll want to populate my buttons again or repopulate them. So I'm going to keep it out here in a separate function. We'll say private void populate buttons. And what we'll do is we'll basically just do a for each loop. So for int I is equal to 0, I is less than, and we'll say something like 24, I plus plus, just like that. And then we could basically just loop through and spawn our buttons. Now, we actually don't have a button to spawn. We're going to need to build a button that is basically the basis of our entire inventory, and that's going to be our item button. So let's build that real quick. So if we head back to Godot here, what we'll do is we'll come over to our first button and we'll just name it inventory button. We should probably stick with the inventory name, because if we call it an item button, then in the future, if we have something that is related directly to items that is a button, we may want to call it item button, whereas this is an inventory button. So we'll keep it on inventory button. So what we'll want to do is we'll want to add an icon, right? Because we need to know how much of an item we have and what it looks like. So we can basically just right click our inventory button, add in a child node, and add in a texture rect. And then we can just drag in our Godot texture just so we can check it out. Now you'll notice that our size of our texture is way too large. So we could just come over here and hit ignore texture size. And if we want to, we can say keep aspect. We don't necessarily need to do that, but if for whatever reason our item has a weird aspect ratio for our picture, we're going to want to make sure we have that on. And we'll come in here and we'll just kind of pull this guy up like so. And that'll give us enough space so that way we can actually see our item in our inventory. Now, we also need to have some kind of label, right? We need to know how many of an object is there. So we'll add in a label like so. Let's just put a 1 in there real quick. And we'll just drag this guy down. And I want this over on the left side, because if we do something like 100, it's going to be way over here. And unfortunately, that's not quite the way we want it to be. I want it to be oriented on the left side. So we'll come over here and we'll do the horizontal alignment and we'll align it to the right. And that way it's aligned over in our corner. And there we go. So now we have 100 of our Godot icon. Simple enough. Now with this, we basically can have the basis of our inventory button, but we're going to need some logic to go with it. When we click our button, it needs to do things and stuff like that. So we need to create a script. If we right click our inventory button and we attach a script, you can see we have an inventory button.cs. We'll go ahead and take that and say create. Now, with our inventory button, one of the big things that we need to focus on is we need to build out something that's simple. It needs to handle the ability of being updated. It needs to house the current item it has. It needs to house its icon, and it needs to house how many of an object it has, and preferably it needs to house its index. Okay, so we'll have all of that up here. So first we need to house which item we actually have. Now we actually don't have any code for an item. That doesn't exist just yet, so we're going to have to build that. But we do know that we're going to need to house our texture rect, right? We need to be able to set our icon. So we'll say private texture rect icon. And then we'll also need to house our label. So we'll say label like that. and we'll call that quantity label. We'll also need to hold our index. So private int index. And the reason why we want to house our index is because there is times that we might want to know, hey, what index is this object? Where is this inside of our grid container? So that way we can keep track of where we are in our stack, if that makes sense. So we need to actually get our icon and our quantity label. So let's come down into our ready here and let's basically set that up. So we'll say icon is equal to get node, and we'll say texture rect like that. And we'll need to get our quantity label. We'll say quantity label is equal to get node label, and we'll pass in our label. So quote label, just like that. Now, once we have these guys, we need to be able to update them and set them. So let's create a function for that we can call later. So we'll say public void update item like that. And then we'll pass in an item and an index. Now, we can't actually pass in an item to update this because we don't actually have an item built out. So we need to build that. So let's head over to Godot here and let's create a script. So we'll right click on our RES, we'll click new script, and we will call it item.cs. And we're going to come to our inherits. We're going to click on this and we're going to type in resource. And it's going to inherit from a resource. This is going to give us the maximum amount of flexibility that we could need for this item. It basically allows us to edit our item inside of our file system. So that way we don't have to go in and mess with any save files or database entries or anything like that. We can just do it right here. And for our template, we'll just do object empty and we'll hit create. And you'll see it's going to be created right here, and that's fine for right now. So we'll just double click that and you'll see that we have a public partial class item resource. Now an item needs to house all of the data that we need an item to have. And in our case, it's going to be pretty simple. First, we're going to house an ID. So we'll say public int ID. And then we're going to need to house a name. So public string name. Then we'll need to house a resource path. And the reason why we're doing the resource path is because if you click on this button, if you want to spawn something, you're going to need to have that resource path. That resource path will allow us to say, okay, you've clicked on the thing and now we want to spawn it. So for instance, if you were building a strategy-based castle building system, this would be a way to handle that, is you would have your resource path inside of your objects. And then we'll say public texture 2D icon. And that's going to allow us to have an icon. And then we also need to know how much of an object we have. So public int quantity. And I need to make that a capital Q. There we go. And then we need to know how much we can actually stack. So with our inventory, you can stack objects on top of each other, but there's always a limit. So for instance, if you pick up, 5 matches versus 500 matches, do you want to allow them to have 500 matches on a single stack, or do you want them to have maybe 5 match increments? So they have 100 5-match increments. And you always want that to be flexible. So we'll put that in here as well. So public int stack size like that. And then finally, we need to know if it's stackable. So we'll check for that as well. And now we just need to export all of these guys because they're not going to show up in your editor if you don't actually export them. So I'm just basically going to copy and paste these guys in like so. And I got an extra export in here, but that's okay. And there we go. Now, if we head back to our inventory button and we scroll up, we can create a private item inventory item. And that'll allow us to have that item on our object. And now all we have to do is basically just update that item. So we can say item, comma, int, index, like that. And then basically we could just set our stuff up. So we could say this dot index is equal to index. And then we could say inventory item is equal to item. And that'll basically update those items up here and set them up. And then we'll hit Control S, we'll come over to our inventory, and then we'll populate our buttons. Now I know we're recursing all the way back up to our inventory buttons, but I promise that this is important. So when we want to populate our inventory button, we need to actually set up a way to actually instantiate our inventory items. Now, to do that, we need to create a pack scene. So we'll head back to Godot here real quick, and we'll right click our inventory button, and we will save branch as scene. Now, in my case, I already have a project structure set up, and you can save this wherever you would like. But in my case, I'm going to hit create folder, and I'm going to hit UI, and I'm going to save it inside of there. Now, if I open up UI and I right click and I rename this and Control A and copy our inventory button, I'm going to head back to our inventory here, and I'm going to actually load in my inventory button. So the best way to load our actual pack scene is to actually house our pack scene reference up at the top. So we'll come up here and we'll say private packed scene inventory button. We should probably go with the lowercase I so we stay within our naming convention standards. Now to have a pack scene, we need to load that pack scene. So what I'm going to do is I'm going to give us a resource location for it. Now we already have a inventory button right here, so we just need to load it. So in our case, it's going to be UI/inventory button.tscn. So we'll come in here and just say private string item button path is equal to quote res :/ UI/inventory button.tscn. And I'm going to make this a little bit flexible by coming up here and dropping in an export. And that's going to allow us to set that in the editor. So if we needed to change this for any reason, for instance, if we had multiple inventories with different types of item buttons, we can just kind of load those at will. So now we can just come down here and load in our pack scene. So we'll just say inventory button is equal to resource loader.load as a packed scene item button path. And that'll basically load it and have it ready for our project. So it's going to have it right here. It's going to be packed in on this guy right here. Now we just have to instance this. So we can come down here and we can basically just say inventory button, current inventory button is equal to inventory button dot instantiate as a inventory button like that. And that will instantiate that inventory button. And now we just need to add it as a child to our grid container. So grid container dot add child inventory current inventory button. And last but not least, we need to run our populate button script. So we'll say populate buttons just like that. And then we'll come back here and we will hit play. And you'll see that we have our inventory buttons populated. Awesome. So we have all 24 of our guys populating all at once, which is great. That's exactly what we wanted. Now, I don't like that they have a default icon, and I don't like that they're labeled at 100, so we'll fix that. And we need to set it up so that when we click our buttons, they actually do something. Because right now they don't do anything, and that's a problem. And we also have 24 small errors here, which means that it's something to do with our loop. Now, in our case, it is going to be an issue with node not found texture rect, it looks like, judging by reading the error itself. We're going to have to take a look at that. So first, let's fix this error here. So it's saying that it can't find a node called texture rect. So let's head over to our inventory button, which it looks like that's the issue because it says on the thing, and I can't really show you. So hopefully in post-processing, I can show you guys, but it says right here that it's inventory button number 14 under its ready function. So if we head over to our inventory button.tscn, we have a texture rect right here. If we open up that code, you can see we're looking for texture rect, but I spelled texture rect incorrectly. It's TEXT, not TECT, and that is why we were having issues. So that should solve this problem here. Now next, we're going to want to make our spawn code a bit more generic. So if we head over to our inventory, you can see we have 24. Let's make that an exported variable. So that way we can change it at will. We'll come in here and we'll drop an export like so. And we'll say public int capacity, and I will pass a get set, and I will hit 24 like that. And if we come down here and change this to capacity like that, then we come back to Godot here and we hit build. And then we click on our inventory. You'll see our capacity is set to 24. If we set that to 50 and we hit play, you'll see we now have a scroll wheel and we can scroll down and we have 50 objects right here. And that's basically the reason why we want to make our stuff as flexible as possible, because that way we can update our stuff at will and it makes things a lot easier. Now, I still don't like these little Godot icons and I don't really like this 100 here. So let's get rid of that. So let's head over to our inventory button. Let's go into our texture rect and let's get rid of our texture like so. Let's go to our label and set our label to nothing. So that way it is perfectly empty. Now we just need to set up an item and we need to populate that item. So the question is where do we even begin? So when you want to add an item to your inventory, you need to create a item first, right? And that's where the resources came in. So if we look at our item.cs, it is a type resource. That means that we can actually come in and edit it in the editor. And what do I mean by that? So if we head over here and we right click our res and we go new resource and we double click on resource and we just call this test item.tres. And we come down here and drag our item.cs into our script, you'll see that we have all sorts of parameters. And strangely, it's exactly the same as our exported parameters here for our item. And that's the power of resources. So I can come in here and say, test item, our resource path, we don't have one. Our icon will be the Godot icon. Our quantity will be 2 and our stack size will be 5, let's say. And it is stackable. What this is going to do is it's going to give us an item that we can spawn. Now, once we have our item created, all we have to do is set up our add button, and then we can start coding our actual ad system. So if we come back to our inventory here, we scroll out a little bit, we right click and add in a child node, and let's just add in a button. And this button, we'll just pin it to the bottom right hand corner like that. And we'll come down here and we'll make it about this big, give or take. And we'll just say add item. And what we'll do is we'll come in here. I'm going to name this button add button. And we'll come over here, go to our node and hit button down. And then we're going to copy this guy and connect it to our inventory. Now this is going to open up Visual Studio, so we can come in here and say public void on add button down, and then we can execute some code. Now, when we want to add our stuff, we basically want to have an add function that we can call with our item resource that we're loading. So basically, to add an item, this is where things will get fun. So we'll come up here and we'll just say public void add. We're going to pass in an item and we'll call it item. Now, what we can do is we can basically just add our item to our inventory. Now, we don't actually have a list of items to house what is our inventory. So a lot of times inventories are set up where you just have a big list of items and you basically say, okay, I have everything on this list and these are all my items. We have to create that list. So we'll scroll up to the top and we'll just say private list of item, and we will say items. And we'll make that equal to a new list. And then when we come down here, we can basically just append it to that list. We can just say items dot add item. And there we go. We're adding it to our list. But unfortunately, it's not that simple, right? We can't just add it to our list and say, yep, we're good to go. It's good. We need to also add it to our button. And also, we have a whole mess of other things we have to deal with, right? We have to be able to add our stuff on top of our stack. So how would we do all of that? Well, to add stuff to our inventory and add in a button, we need to basically update a button with that item's information. And that's actually pretty simple. So what we'll do is we'll just loop through our inventory slots. We'll determine if an item is there, and if it's not, then we'll just add it to that item. So we'll just say for int I is equals 0, semicolon, I is less than items dot count I plus plus. And then we can basically just check if our item dot quantity is greater than 0. And if it is greater than 0, then we know that we have to add it to our inventory. We can just say items add like that, and then we can actually go and update our button. Now we're going to be calling update button a lot. We're going to be updating our buttons all the time. So we're going to want to make sure that we actually have this as a external function. It's going to make things a lot easier. So I'm going to put update button, and I will pass in I for my index, and then we'll build that little function. So we'll come down here and say public void update button, and we'll pass in an int index like that. And then all we need to do is go and say, hey, item update button, go update yourself. Remember, we have an inventory button right here. If I drag this guy over here, we have an update item right here. We take in an item and we take in an index. So for us just to update it, we can just grab our grid container, dot get child inventory button, and we can just pass in an index. We can just pass in our index like so, and then we can just hit dot update item, and it's going to ask us what we want to add in. So we have an index, right? So we could just pull back our items I to pass in our index, comma, and we want to pass in our index directly. Now, technically speaking, we could make this a little bit better if we wanted to house our index in our item, but I want to have that flexibility, so I don't want to do that. But if you guys want to do that, of course you can. And we do have a squiggly line here for index, so we'll add that in right here because I forgot. And then we need to call this add. So let's come down here and just called add, and we'll need to pass in some kind of item to add. Now, we actually have a way to load that resource. We could just type resource loader dot load item, and then we can pass in where we want our item to be loaded. So we can type res colon / / and in our case, I'm pretty sure we called it test item.tres, so we'll / it that. So / test item.tres and end quote. And that should do it for us. Take a look. Test item.tres, that should work. Now, if we head back over to Godot here, we hit play, we let the game run real quick, we hit add item. Well, that didn't work, so that's not a good sign. Let's see what's going on. We have any errors? Okay, so I figured out what was going on. So first things first, we need to change this to capacity because of course our item dot size is going to be 0. So none of this code is going to run. Also, in our update item, we're just setting the index and the inventory of that item. So it doesn't do anything that's visual for us to see what it is. So that's the other big reason. So what we'll do is we'll come in here and just say icon dot texture is equal to our item dot icon. And then we'll do the same thing with our quantity label. So quantity label dot text is equal to item dot quantity dot toString. Visual Studio is doing some heavy lifting here for me. So once we do that, it should work. Now, something that we do need to check though is if our quantity is greater than 0. So we're checking for that because of course we don't want an item that has nothing in it, right? But our quantity will always be above 0 because we're not setting it to anything else. So what I'll do is I will check for that to make sure that we're good to go. So we'll just check for that real quick. So we'll say item dot quantity is equal to 0, at least for right now. And we're going to be recoding a lot of this because we're going to have to do stacking and stuff like that. But I just want to make sure that you guys at least see the step here. So we'll save both of these guys. We'll go back into Godot here. We'll hit play. And then we will hit add item. And you will see that we have an item. Awesome. But if we click again, you'll see that nothing changes. We don't gain additional items. So why is that? Well, if we head back here and I drop a breakpoint in here, okay? And if you haven't set up your stuff, check out my tutorial for that. I actually have one that goes through how to set up C#, breaking and things like that. And if you have set this up and you're following my horror series, be sure to go into your project settings, change your run over to your UI inventory scene, and then it will run that scene as its default. So that's just something to keep in mind. But if we hit play and we add an item, you'll see that we will come through here and we have an item right here and it has a quantity of 2. And then when we hit play and then we hit add again and we breakpoint here again and we check this item, you'll see our quantity is 0. So what happened? Why did this break? What happened here? Well, basically, we set our item quantity to 0, and that sets our item, the actual item on our disk quantity to 0, not our actual item in memory, if that makes sense. So we have to take this item and we need to make a duplicate, or we need to make a copy. We can come up here and just do that. So we'll just say item current item is equal to item dot, and we can bring in duplicate and use Godot's duplicate method if we want to, and we can say as item, and that technically works, but it wouldn't be very C# of me to not just do it in C# and show you guys how to build like an actual C# clone. So we can stop our debug, we can come over to our item right here, and I can show you guys how to make a proper clone method. And the reason why I'm showing you this instead of using the Godot method is because this will give us a lot more flexibility for the future. Because if you want to be a developer, you should know how to do stuff without using the engine system sometimes. So we'll say public item copy equals to pointer, and we'll pass in a member-wise clone as item. And what that's going to do is that's going to allow us to have a clonable object. It's going to clone it and it's going to duplicate it and break that link between the two. And then we can just say item.copy. And there we go. And that's another way to handle this. Now, of course, if you want to use duplicate, you can. That's fine. But I wanted to show you guys this because it's, I guess, fancier. And now all we have to do is just relink our items here. So item.quantity, 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 and just switch them all over to current item. And now if we go back to Godot and we refresh, if we've done it correctly, this should work. Well, kind of. It broke, right? We have a 0 here instead of a 2, and we didn't get an additional object. So what happened? Well, we went for each I in capacity, we got our first element, and then we added our item, and then we updated our button with our capacity. And then we did it the same thing, but we grabbed the same button and updated the same button. And that's what broke our system. So that means that we need to make our stuff a little bit more efficient, a little bit better than what we have here. So in the spirit of that, what I'm going to do is I'm going to pull this guy out. I think it'll be easier if I pull this guy out instead of looping through here, because now it'll automatically append and that'll solve that problem. And then we can just say items.count -1, and that will solve that. And basically what I'm saying is, hey, if we have any items, we're going to add them, and then we're going to update our button minus our count, because our children index is 0 and our count index starts at 1. So that'll solve that problem. And that should solve the issue. We'll keep this for each loop because we're going to need it for later when we do stacking. So let's take a look and see if that solves that. So we'll hit refresh. We'll hit add, and it works. Now we just got to get stacking to working. So you can see that we have a value of 2, but our stack size is 5. So we need to make it so we can stack on top of each other if we are able to. And that's where a lot of fancy coding kind of comes in. So the first thing that we have to do to get that to work is we need to loop through all of our objects to determine if we actually have that object, right? If you add an object to an inventory, you need to say, hey, do we actually own this object? Does it exist in our inventory? And if it does, then we can append. So we're going to loop through our inventory with our for loop here. Then we're going to say if items I.id is equal to current item.id. And then we also want to check to make sure that it's not past its stack size. So and items I.quantity does not equal our items I.stack size, like that. And there we go. Now I'm going to close these two guys so that way we have a bit more space here. Once we know that we can stack this on top of it, so once we can say, okay, our quantity is not our stack size, right? So we can add to this object. Now we can add our stuff. So we can say, okay, we are able to add. How much can we add? How much are we able to add? So if items I.quantity plus our current item.quantity is greater than items I.stack size. If it is, then we can basically just append it and then we're good, right? So items I.quantity is equal to stack size, and then current item.quantity is equal to items I.stack size minus current item.quantity. And then we need to update our buttons. So we'll say update button, and we will pass in I. Now, what this does, and I know that I didn't really explain it very well. So what this does is basically we're saying, hey, if our quantity plus our quantity, so if our item that we currently have in our inventory slot, so the first, let's say the first index in this square, if our item.quantity plus our current item, so the one we're introducing in, is greater than our stack size, then let's set our quantity equal to our stack size. So our quantity suddenly becomes max of what we can hold. And then we're going to minus our quantity from our stack size minus our quantity. That way we know that our current item quantity will reflow down here. It'll get caught and it'll say, hey, we're good. We're going to append the leftovers. But also we have to check what happens if it isn't greater. Well, then else we can basically just say items I.quantity plus equals our current item.quantity. Current item.quantity is equal to 0. And then we can just update our button like we just did. And basically what this will do is it'll say, okay, cool. Our quantity is 0. We're good to go. Our update button, we're going to update our button. And then when we come down here, it's going to check if it's greater than 0. It's not. So therefore we're good. and it's not going to append it. So what does this mean in practice? Well, basically, if we come to Godot here and we hit play and we add an item, well, we have a broken project, so that's good. Let's take a look at it. Index was out of range, must be non-negative size of collection. So let's double click this guy. You'll see it's on inventory 43. So right here, it's mad. It says, hey, your stuff is broken. That's because we're checking if our items .id, blah, blah, blah. Let's see. That's because I'm dumb and I did capacity. I'm going to be fighting with this all day. So we'll change this to items.count. We'll hit play. We'll hit add. And you'll see that it's, well, kind of working. 3, 2, 4, 5. So that's not quite what we want, but it is doing sort of what we want. So let's take a look at our code. So we're updating our button with our index I. We're sending our quantity with our stack size. We're updating our quantity here. Item quantity equal to stack size. So this part's working. So I think this part's good. I think it's this part that it's mad about. Plus equals quantity. Quantity is equal to 0. Our append code's definitely working, so it's something with this small little bit here. What happens if I do this? Minus that. Let's flip these guys. I don't think this will do anything, but let's try it. See if this works. Maybe. Let's see. Definitely not what is wrong. So let's throw a breakpoint here and here. And let's just hit play. It's going to run Godot real quick. And we'll check this out. So add item. Item.quantity, which is 0. I'm going to have to take a deep look at this one because it's confusing. I will be right back, I guess. Okay, so I figured out what it was. So basically, for whatever reason, and I'm not fully sure the reason, but because I set current item.quantity is equal to 0 here, it completely broke everything. And I'm not fully sure why, because once we exit, we're doing a member-wise clone here of this current item here. So it shouldn't matter one way or the other, but for whatever reason, if I do that, and then I go back to Godot and I hit play, if we hit run 2, 4, 3, 5, 2, 4, 3, so now it works perfectly fine. So my guess is that there's something to do with how it is doing the clone, that it's not liking that I'm changing the current item dot quantity to 0, even though I do it up here and it doesn't seem to break anything. For whatever reason, at least with this section here, it breaks the entire system. So that's interesting, but that's okay. So once we have this, now we need to handle the use case of what happens if we have multiple items come in that are above our stack size. And what I mean by that is if we go here and we go into Godot and we grab our test item and we say, okay, we're going to add 15 to this. Okay, so we should have 3 stacks of 5, right? Well, if we hit play and I hit add item, you'll see we have 2, 4, 5. And I don't feel like that's saved. So let me click off of quantity and let's try that. You'll see we have 15, which is a problem, right? Because, well, we can't have a 15 stack size, right? That's impossible. We can only have a stack size of 5. So how can we fix that? Well, when we do our check, we are just checking if our quantity is greater than 0. We're not checking if our item is under our stack size. We have to check for that. So if our current item dot quantity is less than our current item dot stack size, then we can actually add it to our inventory. Else, we're going to need to do some finagling. So first, we'll need to duplicate our item because we don't want to change our item's quantity. So we're going to have to say item temp item is equal to our current item dot copy, because we can use that bitwise copy that we built. And then we can basically just say temp item dot quantity is equal to current item dot stack size, like that. And then we can say items dot add our temp item. And then we can update our button. And then we can just say current item dot quantity minus equals our current item dot stack size. And then we just have to recall ourselves. So add our current item. And that will work. So basically what we're doing is we're saying, okay, I need to make a duplicate of my item. I need to add that item to my items. And then I need to minus the difference between those items and then re-add it. So it comes back up here and calls it again. So basically, if we have 15 of this, we're going to call this add function 3 times because our stack size is 5. We'll have 3 instances of this one item. So if we head back to Godot here and we refresh, hopefully that will work. So we can hit add and we have 3 of them. And it's that simple. Awesome. So that's basically how we add items. Now we just have to create removing items, and that should be just as simple. If we come over to our add button and we duplicate it, we drag this guy over here like this, and we say remove item, like that. We can change our name to remove button, like that, and we can come to our node and we can disconnect our method, like that, and we can connect a method. I'm going to copy this guy, I'm going to click connect, and I'll scroll down to the bottom, and I'll say public void on remove button down. And basically we'll just do the same thing we did for our add. So we'll just come up here and we'll just say public remove void remove, like that. And we're going to pass in an item like that, just like how we did our add. So if I minimize this guy, so it's going to be the exact same thing. Now, when we want to remove our items, we need to do the same thing. So we need to do a clone. So item is equal to item.copy, like that. And then basically we can just loop through our stack, find it, and then remove it. So we'll say for int I is equal to 0, semicolon, I is less than items.count, semicolon, I plus plus. And then we can basically just remove our stuff. So we're going to loop through our inventory. We're going to check to see if we can remove it, and then we'll remove it. So if items I.id is equal to current item.id, because we need to make sure it's the same item. And then we can just check if we can actually remove the item. So if items I.quantity minus current item.quantity is less than 0, then we know that we can actually remove. So here we're going to check to see if we can remove it. So basically we're saying, hey, if removing it is more than 0, then we know, or is less than 0, then we know that we can just straight remove our stuff. So we can just come in here and say current item.quantity minus equals items.quantity. And then we can just say items I.quantity is equal to 0. And then we can just update our button like we did before. So we'll just pass in our update I, and then we can just do the same thing we did for our add, which is if it's not less than 0, then we know that we can remove it and not have to worry about setting our item quantity to 0. So we can just come in here and say items I.quantity is minus equal current item quantity, and then current item.quantity is equal to 0, and then we can just run update button I. And Visual Studio is again doing a lot of heavy lifting here. Now, once this happens, once we get past this, we basically need to come in here and check if our current item.quantity is less than or equal to 0. And if it is, then we're good. We're done. We don't have to do anything else, so we can just break. So what this is going to do is it's going to loop through each one of our inventory items, and it's going to check if the ID is good. And if it is, then we know that we can subtract it from our inventory. And that's basically how it works. It's pretty simple. And then once we have all of that, then we need to flush our item inventory of any objects that don't have any quantity, right? We don't want any items just lingering around in our inventory. We could just say items dot remove all where x pointer x dot quantity is less than or equal to 0. And that'll basically just clean up our inventory and make sure that we're not having any stragglers or any hanging inventory items. It'll make things a lot cleaner for us. And then we could basically just say if current item dot quantity for whatever reason is greater than 0, then we know that we could just recall our remove item. We could just call our remove and we'll just pass in our item. And now we basically just need to tell our system to update all of our buttons, because we don't want our buttons to be incorrectly assigned, right? So when we delete something, we just want to make sure that all of our buttons are updated, that everything is copacetic within our stuff. Kind of like how we're doing this remove all, we basically just want to make sure that everything's happy. And now we don't technically need to do this, but I just like to make sure. So I'm going to come down here and I'm going to create a function for that, because that way, in the future, if we need it. So private void reflow buttons. And what we'll do with this reflow is we'll basically just go for int I in, and for our length, we'll just say capacity. So our entire button stack, we'll just update our button and we'll just have it update itself. That'll basically allow us just to make sure that everything's good. Now, we don't necessarily have to do this, but I would like to do that just in case. And then we'll scroll down to our remove item button and we'll just go remove, and we'll pass in our resource loader.load item right here. So we'll just paste that guy in and control save. And then let's hit run and let's see what it does. So if we add and then we subtract, you'll see it kind of did what we wanted, but we're missing some stuff here. So we have zeros, which is part of why I wanted the reflow, was so that it would fix this, but it doesn't seem to have fixed it. So let's see what's going on here. So let's see. Remove. Oh, we didn't call reflow item. That's why. So reflow buttons like that. And then let's see if that works. So let's refresh. Add, remove. And we have a debugging error. Must be non-negative. Index was out of range. Must be non-negative. I index. Update button. Items index. So here is where we have a problem. So you can see here, it's broken. It's saying that our index is out of range. And that's because our system, our update button, does not have the ability to check if that index exists. We're not doing any error checking, and we need to do that. So what we can do is we can come up here and just say if items dot element at or default index does not equal null, then we can do this guy here. Else, we can go ahead and basically update our items as well. So what this is going to do, if I I'll just grab this bit of code here just to make it a little easier on us. We'll paste it and I'll just pass in null. What we're doing here is we're just checking if our element exists at that location. So I'm saying, hey, do our items have a element at index? And if it's null, or if it's not null, then go ahead and just set it. If not, then go and set it to a null object. And if we take a look at our update item, right now we don't have any code settled for that. So we're going to need to actually calculate that and code that, because it's going to break if we don't do it properly. So let's update this. So we'll hit enter and we'll just say if current item is equal to null, then we can basically just say icon.texture is equal to null, and then we can just say quantity label.texture text is equal to string.empty, and then we can just check else, and we can pass this in like so. And I'm going to format that real quick. And that'll basically handle it. So basically, if an item comes in and it's null, then we're just resetting our button back to its default state before we set our texture and our quantity. We're basically just saying, if this is null, just don't worry about it and reset it. And that should fix that little error right there. So if we come back and we refresh, and we hit add, and we hit remove, you'll see we remove 5 and we remove again 5. And that should work. Now, what happens if we change this to 15 to something like 3? Click off of it. And we add, remove, and then remove. I think, yep, we just broke it. We have a Stack Overflow. So we have a bug. So one of the things that's not great about this system so far is that we're checking if we can remove our item. We're removing our item, and then we're just checking if our quantity is greater than 0, and then we're just removing it. But unfortunately, that doesn't quite work fully in all cases, because what happens if we want to remove 3? We only have 2. Well, we'll remove the 2, and then we have that 1 floating around, and our quantity is greater than 0, but our for each loop isn't running anymore because we don't have any more of that item that exists. So therefore, we're just going to keep looping right here, and it's going to keep that working thread open, and it's going to cause a lot of problems. So what can we do to solve that? That is where the ability to check if we can afford that object comes in. Let's create a function to do that. So we'll come down here, and we'll basically just say private bool can afford item, and we're basically going to check if we can afford this item. And this is where link comes in, and link is magic. It's one of my favorite things about link. We'll just pass in a list of items like so, and we'll say current items is equal to items dot where x pointer x.id is equal to items.id to list. And once we have this, all we have to do is just get the count of that object. So int I is equal to 0. I mean, we could go int count if we wanted to. Then for each var item in current items, and we'll just say, instead of item, I guess we'll just say item 1 in current items. I mean, that's not exactly ideal, but we'll deal with it in a second. I plus equals item 1 dot quantity. And that'll allow us to pull back our item quantity. And then we can basically just come down here and say if our item that we're removing dot quantity is greater or is less than our count that we have here, then we can return true. Else, we'll just return false. Just like that. And that'll basically allow us to say, can we afford this? And then in our remove code, all we have to do is just check if we can afford it. So we'll just come in here. And before we even create a copy of our item, we'll just say if can afford, and we'll pass in our item. And then we can just bring all of this down here and drop it in like that. Now, something else we should do is we should check if our remove was successful. And the reason why is, in this case, I'm not going to use it, but you guys probably will if you're creating a crafting system or something like that, right? If you want to remove elements from that, you want to know that that was a success. So we'll just say Boolean, if I can afford it, then we can return true because we know that we can afford it. So therefore it will get removed. And if not, then we can return false like that. And that'll basically just clean us up, make sure that we're okay and that we're good to go. And now our add and remove system should just work. So we can just hit play and we can add, remove. And you'll see that when I click remove, it doesn't crash. We don't get stuck in anything. We just can't afford it. And so it doesn't break anything, which is awesome. So that's basically adding and removing in a nutshell. Now we just need to go and build out our ability to click and drag and rearrange items. And then we'll just create a trash so we can remove items. And then we should be good to go. Now, first, we need to set up some way to know if we're over top of an item. So when you come up here and you take a look at our inventory, at our grid container, our buttons just kind of exist and we don't really know which ones were over. We don't know which ones were near or anything like that. And it would be really nice to know exactly which ones were over. Now I'm going to do this by using area 2Ds. Now I know that you can use, if you come to your inventory button and you click on it and you go over to node, I know you can use mouse entered and mouse exited. But the problem that I have with mouse enter and mouse exit is sometimes it fires when it's not supposed to, or sometimes it's just not as flexible as I want it to be. So if you guys want to use this, you're welcome to, but in my case, I'd rather just do it manually. Sometimes manually is easier, at least for me to understand. What I'm going to do is I'll come in here. I'm going to right click my inventory button. I'm going to add a child and I'm going to add in an area 2D. And then I'm going to right click, add in a child, and I'm going to add in a collision shape. We're going to come to our inspector, click on our shape. We're going to add in a rectangular shape and we'll make it about this big, give or take. I'm not going to make it cover the whole button, just almost the whole button. And the reason why is I want to make sure the mouse is fully into the button before it makes that collision detection, before it fires off that event. Once we have this, we're basically good for our inventory button. We don't have to come back to this for pretty much anything other than when we click on it, and that's something we'll do in a little bit. But if we go to our inventory, we need to be able to know when we're over top of a button. And since we're using an area, we're going to have to use an area to actually follow our mouse cursor. So we'll come in here, we'll right click, add in a child node, and we'll add in an area 2D. And we'll right click, add in a child node, and add in a collision shape 2D. And we will add in a new circular shape. Now, if we zoom in here, we're going to want to make this really small, because if it's large, then it may interact with other buttons when it doesn't need to, and then it can cause a lot of problems. We'll make it nice and small so it doesn't have that problem. And then we'll select this and just call it mouse area 2D. And then we'll come into our inventory and we'll basically just add in a process function, which we already have, but we'll add in our process function and we will get our area 2D to follow our mouse. So we'll come in here and we'll just say get node area 2D, and we will call it quote. Our path is pretty simple. It's basically just inventory mouse area 2D. So we'll just copy that and we will basically paste that guy in. Dot position is equal to, and we'll get our tree. Dot root dot get mouse position, and there we go. Now, once we have that, we're pretty much good to go. It's going to follow our mouse and we're going to have no problems. Now we just need to set up our collision stuff so it works. So we'll come over to our node. We'll say on area entered, on our inventory, and on area exited. And actually, I should have, because C# support is finicky at best in Godot. So I will copy that and I'll come down here and say public void on mouse area entered. Now, if you're not following the Godot C# tutorial series that I've been working on, you come in here and you take a look, you can see it says area 2D. So that's nice because it tells us what it is. So it's an area 2D area, like that. That's an easy way to know if how a signal hooks up. That's a really simple way to find out how that works. And I'm going to connect my area exit. So connect, and we'll copy this guy, connect, and we'll come down here and we'll do the same thing. So public void, and we'll paste this guy in area to area. And you can see here is our area exit and area entered. Now, all we have to do is we just need to make sure that we know what object we're hovered over. We're going to create a reference to some kind of button because when you're doing a grab and move system, you need to know what object you're over and you need to know what object you have grabbed if you have any grabbed. So what we'll do is we'll come up here and we'll say public inventory button grabbed object, and we'll just do get comma set, and then public inventory button hover over button, and we'll do get comma set. So basically what this is going to allow us to do is we're going to have a way to know who we're hovered over and if we have a button grabbed. And that'll give us a lot of flexibility in the future. Now, if we come down to the bottom, we can basically just set our hover over button. We know that we're returning that area, so we have to get its parent. So we can just basically say control button is equal to area dot get parent control, and then we can just say if button is an inventory button, then we know that we're good, that we're able to actually pass this object back. So basically we can just say hover over button is equal to our type inventory button, and that'll basically set up our stuff. Now I did miss my capital I, so we'll do that, and that'll basically solve that. So every time we hover over an object that is a control node, this will fire off and basically we'll set our hover over button as this if it is an inventory button. And then we can do the same thing down here, except for we don't necessarily need these guys. We know that we are exiting our area, so really we can just pass a little inline function here and we can just say hover over button is equal to null. And that just kind of cleans up our code a little bit. We don't necessarily need to do it that way, but that's how we can do it. So if we have a null hover over button, that makes things a lot simpler for us. Now we have our detection system pretty much done. Now we just have to make it so that when we click and drag, our object follows our mouse, okay? And the way we're going to do it is we'll just kind of duplicate that object and then hold it on the mouse cursor and then move it, basically. I think that'll be the easiest way to do this without having too big of a problem. So we'll come up to our process node here. So if I hit Control MO to minimize all these guys, to collapse them, I go into my process here. What we have to do is we have to check if our hover over button is null or does not equal null. Basically, if it's not null, then we know we are currently hovered over something. Pretty simple. And then we have to detect if we have a click. Because when you want to click and drag and move an object, you need to know, right, if you've clicked on this thing. So if input dot is action just pressed, and in my case, I have throw already set up. Now, if you're not following this as part of the Godot horror game C# series, then you need to set that up. So if you come over here into Godot, we go to project settings, and then we go to input map. I added in the throw map to my left mouse button. And you could do that basically just by coming in here and typing, for instance, if we wanted to do the left mouse button, let's say left mouse button click, like that. We could just click on this little plus icon and then we can type mouse like that, and we can just right click or left click. So in our case, we were doing left mouse button click, and we can hit OK, and there you go. And that's how you do that input map. It's pretty simple and pretty quick. Now, if input is action pressed throw, then we know that we're clicking down. So our grabbed object is equal to our hover over button. Now we do have one other thing that we need to check, and that is what's the difference between clicking an object and clicking and dragging an object? If you want to click an object and you want to say, I want to use this object, that's just a click without any mouse movement. But if I click and I drag the object, I'm moving the object away from its original center point, and I'm basically moving it over. So the way we can differentiate between the two is by keeping track of where we clicked when we clicked our button. So what we'll do is we'll come up here and add a vector2 for that. So private vector2 last mouse clicked position, like that. And then we could just set that up. So last mouse clicked position is equal to get tree dot root dot get mouse position. And that'll pull back our mouse position and set this value. And I'm doing that so that way we know that our mouse position is where our last clicked position was. And now we need to determine if we've moved far enough away from our inventory slot to determine if we've clicked and dragged or if we just clicked on it. So how we can do that is just by checking our distance. So if last clicked mouse position dot distance to get tree dot root dot get mouse position, like that, is greater than something like 2 or some kind of value, then we can run our code. So now we can guarantee that we have clicked our mouse and we have dragged our mouse. So now all we have to do is just check to see if we're currently holding down or if we've let go. So if input dot is action pressed throw, then we know that our inventory button is being dragged. And that is where we need to set up an inventory to be copied, right? So we want it to follow our mouse cursor, right? So for it to follow our mouse cursor, we need to give it some kind of copy of the item that we have. So how we can do that is if we come back here, we can basically just drag in an empty inventory button onto our mouse area like that. And we'll make it just a touch smaller maybe, or maybe we'll keep, actually, no, I think I'll keep it the same size and we'll just hide it. And then when the user clicks and drags on the inventory, this guy will show, it'll get populated with the data. And then when they let go, this guy will hide and it will de-instance it from where it was to where it is now. And that'll create the illusion that we picked it up and dragged it and moved it. So how we can do that is basically we'll just come in here and say inventory button is equal to get node area 2D. And I believe we called it mouse area 2D. So we'll paste that in. Dot get node inventory button. And I believe we just called it inventory button. So we'll just copy this guy like so. Quote paste. We could just say button dot show button dot update item, and we can pass in our grabbed object dot, and I believe we had a item called inventory item, but it's not coming up. So let's take a look. Let's peek definition and then just peek definition. Item, inventory item. Yes. So inventory item. It's inaccessible because it's not public. So we'll make it public. So public item, inventory item. We'll control R to rename, and we'll hit capital I for inventory item. That way everybody kind of follows that proper naming convention. And then we will come in here, we'll hit comma, and then we got to pass in an index. And thankfully we don't really need an index. So we'll just hit 0, and there we go. And that will set up our ability to grab and have it follow our mouse. And then we can basically just say if input dot is action just released, quote, throw, then we know that you've let off of your mouse button. We also know that you are currently dragging. So that means that if you're dragging and you've let off your mouse button, then that means that you must want us to swap those buttons. So to do that, we will basically do some fancy magic here. So first we'll just say int button index is equal to grabbed object dot get index, like that. And then we'll say int button to index is equal to hover over button dot get index. And then we'll just basically tell our grid container to move our children. So grid container dot move child grab object button to index. And then we'll basically do the exact same thing, but instead with our hover over button and button index. Now I know what you're thinking. Why would I do it this way? Why can't I just pass in my grab object index into my button index and my hover over button index into my grab object index, right? And basically just pull this guy and throw it into here, and pull this guy and throw it into here. Now, the reason why is because if we do that, this object's index changes based off of where it is in the child stack. So when you change the object index of something that's a child, this object's index also changes, right? It gets reflowed by 1 or 2, depending on wherever you throw it. So we don't want to do it that way. So that's basically the reason why. Now all we have to do is just hide our inventory button. So I'm just going to get a re-reference to this button. And then I'm just going to say button.hide. And there we go. And that should basically do all of our swapping system. So if we head back to here and we hit play, we'll test all of our code and see if it worked. So we'll come in here, we'll add an item, we'll drag it. You'll see it gets duplicated like we expect. We'll let go, and it goes into the proper inventory slot. If we add 2 additional items, let's go like this. We have 3 and 5. We drag this guy on top, 3 and 5, and they swap properly. Awesome. Now there is a little bit of refactoring I'd want to do. So for instance, this guy should probably be its own function just for sake of clarity and so that things are a little bit cleaner. So I'm going to right click this guy, quick actions and refactoring, extract method, and I'm going to call this a swap buttons. And I'm also going to make it so that instead of it taking this guy in, I'm going to make it abstracted out. So I'm going to just take in an inventory button. We'll just say button 1, inventory button, button 2, just because it makes things a little bit cleaner for us. We don't need to deal with as much garbage if we want to do this again. So I'll just take both of these guys and throw them in like that. And then I will grab button 1 here and then button 2 here. And that will basically make it so that everything works the same, but it will allow us to have our stuff work. And we could just put grabbable object and hover over button like that. And that'll basically just clean it up, make it a little bit nicer. So that way we have what's called a utility function here that just does one thing. And that's all it does. It swaps 2 buttons and updates their index. Now, all we have left is the ability to use a button and the ability to delete stuff. And that should be pretty quick. Now, to delete items from our actual inventory, all we have to do is come in and basically create a trash. Now, you could do other ways, like, drag it out and drop it outside of the object or something like that, or outside of the inventory if you wanted to do it that way. But in my case, what I'm going to do is I'm going to come into Godot here, and I'm going to come down here, and I'm going to select my scroll container. And the first thing I will do is I'm going to right click, add in a child node. I'm going to add in a panel because I want some kind of backdrop to this guy. We're going to go to our inspector and we'll go into our theme, overrides here, styles, and I will drop in a style box flat. That way we have something. And I'll just kind of throw this underneath our scroll container here. I probably shouldn't have done my scroll container first, but that's okay. So we'll just drag this guy here. We'll just kind of snap this guy, I don't know, probably about here. And I'm way off as usual. So that works. I'll just kind of bring this over just a touch. That's close enough. And we'll just grab our little panel, drag this out a bit. We'll bring it up above our scroll container, drop our scroll container in it. And what I'll do, I'll right click my panel. I'm going to add in a child node. I'm going to add in a button. And the reason why I'm picking a button is just because I like the look of buttons. You don't have to do a button. You can do basically anything you want. And I'll put it right about here. It's just outside of my inventory. And what I'll do is in my button, I'm going to call it trash like that. And we'll right click our trash. We'll add in a child node. We'll add in an area 2D. And basically, much like before, we'll add in a collision shape and we'll make it a rectangular shape. We will size it up so it matches. And basically, like before, what we're going to do is we're going to basically determine if we're over this object. And if we are, then we know that this is a trash object. So I will come over here. I'm going to come into my area 2D for my trash. And I'm going to say, hey, on area entered, I know I'm in my trash. So I will drop that into my inventory. And I should probably name this something. So I'm going to call this trash area 2D. And then double click on that, Control A, Control C, connect it, and then come down here and say public void on trash area entered 2D, area 2D, area, and then we will put our braces in like that. And we're going to do the same thing. We'll double click our area exit. I will copy this, connect it, and then I will scroll down here and I will say public void paste area 2D area, and I will bring that in as well. Now, once we have this, we basically just need to determine if we're over our trash. Now, we know that we are over our trash, right? We do understand that we are over this if we are over our area 2D, right? So all we have to do is basically say, okay, if you're in this, then we know you're over a trash can. So we just need to set some kind of value for that. We need to say, yeah, we are over one or we aren't. So we'll just create a private variable here and we'll make it a Boolean and we'll just say over trash. And then we'll just come down here and we'll just say over trash is equal to true and over trash is equal to false. And that's basically all we have to do. And of course, we can make this a single line, right? If we want to make our code look a little bit better, we can just put a little pointer in like this, and there we go. We have a nice, simple little function. Drop in a pointer like that, and there we go. Simple enough. And now, for us to be able to actually trash our items when we're over it, all we have to do is come up here and check to see if we're over our trash. So we know that we're dragging our objects and then we're letting go. So all we have to do is just check if over trash. If we are, then we can delete our button, right? Else, we're going to swap it because we know that we're good to go. And this here is just for me to do a little bit of checking because I have a section here where I say if hover over button does not equal null. Well, there's a possibility that hover over button may not equal null and we're over a trash. So I just want to make sure that we cover both. So if we're not over a hover over button, we can come in here and just check if input dot is action just released, throw, and over trash, then we can go ahead and delete our stuff as well. I need to put this guy like this, and this. There we go. And that will solve that problem. Now, if we're over our trash, we need to delete our button. And you can see that we're calling this in two separate spots. So it makes perfect sense to create a function call for this. So if we head down here, we can go public void delete button, inventory button, like that. And then we could basically just say items dot remove inventory button dot current item dot inventory item. And then we can reflow our buttons to make sure that all of our buttons are happy. And then we can just set our inventory button. If you remember, we grabbed our inventory button here. We can basically just grab that guy here and then just button.hide like that. And that pretty much does it. So now we can just head over to Godot here, hit play. And if we've done everything correctly, this should just work. First things first, my panel's over top of my scroll container. So that's going to be a problem, I think. Oh, that should be okay. Oh, we have a debugger. Okay, so we got an error here. So let's see. Node not found, scroll container, grid container at, if we look at this, Godot native calls GD extensions inventory 27. So it's mad because we moved our panel into this location. So we'll say panel slash scroll container slash grid container. There we go. And then we will hit play and let's see if that works. And there we go. So now we can add some items and we can click and drag and let go and nothing happens, which leads me to believe that I'm not calling it, which I'm not calling it because I'm dumb. So delete button like that. And then we'll pass in our grabbed object right here like that. We'll copy this and we'll paste it and we'll Control S. Then we'll hit play. Let's try it again. So add, and we'll drag this guy in and it gets deleted. It's like that. Simple enough. All right. And it's really that easy. So now all we have to do is we have to set it up so that when we click on our button, it actually does something. So right now, when you add in these buttons and you click on them, it doesn't do anything, right? It just kind of does nothing. But in inventory systems, a lot of times, let's say you click on a potion, right? You want it to heal your character. You want it to do a thing. So this is where code structure matters. This is where things start getting important. So when we build out our system, we want it so that when we use this item here, this item.cs here, when we use this, we want the item to control what it does when it's clicked on. We don't want the button to control it, and we don't want the inventory to control it. If you do either one of those two, it's not going to be flexible enough for our use case. So how can we do that? Well, here's where the magic happens. If we come in here, we can just say public void use item like that. And then what we'll do is we'll just say gd.print used item like that. That's a simple enough interaction for us to be able to let you guys expand upon it, right? So all this is going to do is call use item. And then head over to our inventory button, and then we can come down here and we can subscribe to our click event. So we can come in here and on our ready, we can basically say on pressed plus equals inventory button pressed. And you'll see it automatically created a function call for us. And then we could just say inventory item dot use item. And now if we come in here, we can hit play like this. We can add some items. We can click. You'll see we have used item. Now, I know that that's not a huge revelation, and it's not like, oh my goodness, my pants have been blown off, right? Like it's not super crazy, but here's where it gets cool. So if I come into my RES here, I right click and I create a new script, and then I come over here, I can inherit this from a node in this case, and then I'll just call it item number 2, or I guess we'll just call it potion. Right? Potion is fine. So we'll just say health potion. And then we can just hit create. And it's going to create a health potion script. And hopefully it'll open it up in Visual Studio Code here. And then all we have to do is just inherit from item, get rid of these guys. And then we can say public override. And you'll notice that, well, it doesn't come up with use item. If we type use item, right? And we do this. And maybe if we make it void so it knows it's a function, you'll notice that we have a little curly brace underneath it. And it says, hey, yo, this doesn't work because it's not marked as a virtual, abstract, or overridden. How do we fix that? Well, we can come up to our item. We can say public virtual void use item. And then if we come over here, we can say gd.print heal the player, like that. And now if we come over to Godot and we duplicate our test item and we just call it health potion, now we have a health potion here, right here. And we could just say name health potion, and our icon can be let's say a gradient texture. I think that'll be an easy one. And then we could say our quantity is 1, our stack size is 10. Actually, let's say quantity is 7 and our stack size is 10. I think that'll be easier. And our ID is 1 because we want to make sure it's different than our other item ID. And we can drag our health potion.cs in here, which it's not going to be happy. So we'll build it real quick. There we go. ID of 2. We'll call it health potion. And then we'll say our icon is a gradient. I should have done this in the beginning. Quantity of 4 and a stack size of 10, let's say, and we'll say it's stackable. And now all we have to do is basically duplicate our buttons right here, these two guys. So Control C, Control V, we'll bring these guys over and I will snap these guys slightly above and we'll just say add button 2, that's fine. Remove button 2, that's fine. And we'll just say remove item 2 and add item 2. And then we can basically just take these guys, disconnect it, connect it, and then I'm going to copy it, connect. It's going to bring up our Visual Studio. We'll scroll down here, paste, public, void, paste, like that. And then we'll do the same thing, but for delete. So we'll grab this guy, disconnect, right click, connect, A, copy, connect. We'll come here, public, void, paste, like that. And then we can basically just grab our remove button and our add button. So we'll just copy this guy, remove, copy this guy, paste, add. And then instead of test item.tres, I believe we had it as a health potion.tres. So we will grab that name. Godot is being difficult. So we'll grab that name. We'll paste it. And then we will paste it like so. And that should be pretty much it. So now, if we hit play, providing everything was set up correctly, if we hit add item 2, you'll see that our gradient didn't quite work, but at least we have it. And if we hit add item as well, you can see add item, remove item, you'll see it subtracts from this guy and not this guy. If I add additional ones, so if I start adding them and I start removing them, you'll notice that they're mutually exclusive, which is good. And if I click on these guys, you'll see it says heal the player. Versus if I click these guys, it's used item. So that's the power of this system, is it allows you to make your stuff flexible. And the even cooler part is if you wanted to add specific parameters to specific items, you could. So if I wanted to, for instance, come in here and say, okay, well, my health potion has a heal amount, right? So I can say this, bracket, export, public int heal amount, and I'll default that to 10, let's say. And I'll say heal the player 4 plus heal amount, like that. When I build this, and I come to my health potion.tres, you'll see it says heal amount is 10. I can also copy and duplicate this. So I'll just duplicate this as heal potion mega, right? And we can double click this guy and say heal amount is 100. Okay. And then if I repoint, so I'm just going to copy this guy's name like this. And if we repoint our inventory here, and we repoint this guy to the mega potion, okay? And we're going to change the picture of the mega potion to be something like actually, we'll just make it our icon.svg. That way we have a different picture for each one. If I refresh this, if I add a couple of small potions and then I add a couple of regular potions, which my fault, I have an ID of 2. So let's change my mega potion to an ID of 3, let's say, and we hit play because they're going to stack on top of each other because they have the same ID. So if we add in and then add in like so, so it looks like I might have found a bug. So somehow during the removal process, unless I'm crazy. No, I'm not crazy. Okay, that works. I just wanted to make sure it was correct. So now if we click this guy, you can see it heals for 100. And if we click this guy, it heals for 10. So you can have a type healing potion.cs that has specific sections for your healing potion. So you could have something like a base sword that has all your base sword attributes, and then you could have extensions and branches among those. And if you guys ever want me to explain how to build a crazy item system, maybe now's the time to revisit the inventory system I built for the 2D side-scrolling game, because there's a lot of stuff that we could do there to make it really cool. But it allows us to have a very extendable system that's really easy to use. And that's the power of resources inside of Godot. At this point, the tutorial is pretty much over, so you guys can drop off now. But if you're following the horror game series, then you might want to stay on. Last but not least, we're going to hook up our player to it. So if we head over to our player.cs and we scroll down, there's a section in here where we handle some input. So if I remember correctly, it is down here. And all we have to do is we can come in here and basically say if input dot is action just pressed, and we'll say inventory, then we will show our inventory. And we're going to need a reference to our inventory. So we'll scroll up to the top and we'll basically build out a reference real quick. So private inventory, and then we'll come to our ready and we'll hook that up. So inventory is equal to get node, and we'll just grab inventory and quote inventory like that. And then we'll scroll down to where our interaction is right here. So we'll say inventory.visible is equal to not inventory.visible. And that's basically going to say if it's visible, it's no longer visible. If it's not visible, then it is visible. And then we'll just check if our inventory is visible, then input.mouse mode is equal to input.mouse mode enum dot, and we will use the visible way. Else, if our inventory is not visible, then our input dot mouse mode is equal to input dot mouse mode enum dot captured. Basically, if our inventory is up, we want our mouse to be visible, and if not, then we don't want our mouse to be visible. Pretty simple. So now if we head back to our Godot project here and we scroll out, if we Control S and we open up our original test scene, so our project scene, so I believe it's under scenes level 1, I believe called it, under levels, and we go to level 1 wake up. So this is our little scene here. If we take a look at our player needs to have an inventory attached to it. So we'll come in here and we'll attach our inventory. So we'll go to UI, inventory, and we'll attach it. And then we'll start it off by being hidden. And then if we hit Control S, we go to our wake up scene, we hit play, and we hit I. Well, A, nothing happens. B, we have a debugger. Take a look at that. We've got some kind of error here. I don't know from what. So I'm going to go into project settings. I'm going to come into general, and I'm going to come in here and I'm going to I'm going to go to levels. I'm going to go to level 1 wake up, set that as my default. And then I'm going to hit play on my profile here and see what the heck's going on. Well, I can't move. I can't jump. I don't have any stuff at all. It's a standing. I'm going to take a look at this. I'll be right back. Okay, so I solved that issue. So it looks like, for whatever reason, I cannot default my gravity equal to something. And I also apparently cannot default my state. So I put those two down here for whatever reason. I don't know if this is a bug with Godot itself or if this is just my really bad coding, which is also very possible. So let's try that and let's hit play. Okay, so we got a null reference exception, which is weird because input shouldn't be running under get input. That shouldn't be running when the player before ready is done, because this is getting set in ready, I believe. Yeah, it's being set right here. Camera.get node raycast 3. So if I take a look at camera real quick, double check this. I want to make sure I'm right here. So camera 3D, raycast 3. So it's definitely there. All right, so I guess what I'll do is I'll check to see if it's null first. So if head raycast does not equal null, then do this bit here. I'm assuming that we're going to have another issue throughout our code on this. There's another error. So our light value is 0. Object not set to an instance of an object because our light detect object has not been set. And that hasn't been set because ready isn't running. So does ready no longer run automatically on startup? Or is there something that I missed? I just upgraded to Godot beta 10. So I'm going to check to see if there's a new beta. Maybe this is just an issue with the Godot beta. Let me take a look and see what they have. So it looks like if I take a look at the Godot beta here, if we come into the blog, it looks like we have Godot beta 14. So I am behind by a fair amount. So let me come down here and grab the .NET 6 build, and let's try and see if the new build maybe fixes some of the issues that we're running into. Close this version of Godot, and then let's open up our version here. So we'll extract it, and we'll double click. We will open it. I'm going to have to pin it to my taskbar again because this is a new version. So unpin my previous in the newest one. I try not to upgrade betas very often because the Godot team breaks things and fixes things really, really often. So I like to know what's going to break versus not know what's going to break when I do tutorials. So I will double click this guy and let's see if this will fix our issue. I hope so, because that's not ideal. So let's relock this in. And I do like this new button here. That's fancy. Let's go ahead and hit play. And I have a non-buildable code. That's not. Let's see. What do we got? Oh boy, they changed all of the things. Let's take a look at it. If I stop this guy, I go to build, rebuild. We have a failure. Navigation agent does not contain definition for set target location. So they must have moved that. That's cool. So let's see what's going on. So we'll come up here. Navigation agent dot set. All right. So we don't have set target location anymore. Awesome. What do we have? Dot target location, it looks like. So waypoint 0 dot global position. So it looks like they got rid of the function call and instead made it a parameter, which I don't really like, but I'll live. They have target location is equal to instead we're going to set it equal to our player dot global position. That don't like it when you change these, breaks everything for me, but okay. All right, try that. We'll rebuild, and we still have a failure. Navigation agent 3D does not contain that. We'll just tab her over, get her in there, and then let's build it again. And there we go. And this is one of the reasons why I tend to not upgrade when we do these things, because sometimes things just break and I don't know why. So now we'll just hit play and there we go. Cool. So our code's back to working, or at least it looks like it's mostly working. So if I hit I, you'll see our inventory comes up. Our mouse does not lock, but that's okay for right now. We can add items. We can click on them. Cool, that seems to work. We can remove items. Oh, and I did just crash it. And that's because the object doesn't exist. So that's something we'll have to look at. So to fix our mouse moving around when we have our inventory up, we just need to check for that. On our player, Control MO, we have a section called input right here. We basically just need to check if our inventory is open. So all we'll do is we'll just check if our inventory event is mouse motion and our inventory dot visible. And that'll basically do it. So if our inventory is not visible, then our camera's not going to move. Or if our inventory is visible, then our camera's not going to move. And if our inventory isn't visible, then we can move. Simple as that. So now we can just hit play. We'll have our character looking around. We hit I. Our mouse no longer is being captured. We hit I. Our mouse is back to being captured. And then we can add items like that. We can use them. You can see heal the player for 100, heal the player for 10. We can delete items. We can add items. And we can move items. We did have a crash. See if I can cause that to happen again. Oh, there it goes. So because we have an inventory item, we need to check to see if it's not null. So if inventory does not equal null, and that's what's causing our crash right there. So now the reason why I was crashing was because when we click on our inventory, so if I hit I and I click, this was coming back as null, which was crashing Godot. So that's pretty simple. But that's pretty much all I have for you guys today. So in our next video, we're going to create a Resident Evil style where you can click on the object and rotate it and see it and investigate it. So the idea is, for instance, if you pick up like a note or something like that, you want to be able to rotate the object and take a look at it and read the note and things like that. So that'll be what our next tutorial will be about. So look forward to that. But that is all I have for you guys today. So if you like this video, hit that like button. Hey, if you dislike this video, go ahead and hit that dislike button because I'm here to make content for you guys. This video was a viewer suggested video as with all of my videos. So please, if you have any suggestions, throw them in the comments below. I'm always happy to come up with new ideas and to build new things and to, help you guys in the best way I can. That's what I'm here for. And hey, if you have any questions or comments, throw them in the comments below or hit me up on Discord and I'll be more than happy to help you guys out. Or really anybody on that Discord will help you out. There's a bunch of wonderful people over there and it's a lot of fun. But that is all I have for you guys today. So thank you so much again for watching. I'll see you all next time. Thanks.